I'm very honored to take part in this summit and introduce you to Creus Moreira. He's obviously a technology entrepreneur and cybersecurity expert, and the founder, chairman, and CEO of WISeKey and CLSKey, both quoted on the NASDAQ. He leads global companies focused on digital identity, cybersecurity, secure semiconductors, and trusted technologies. Before founding his companies, Carlos worked for many years as a cybersecurity expert with United Nations agencies, contributing to global frameworks for digital trust and cyber resilience. He is recognized thought leader on cybersecurity, digital identity, and AI governance, and actively participates in international forums, shaping a secure, human-centric digital future. Thank you for being with us today, Carlos. First question, could we first talk about digital identity, which is becoming essential for society and the economy? What are the key things needed to build digital ID systems that people can trust, that can scale globally, and that protect privacy at the same time?
Thank you very much, and thank you very much for having me. So the internet, the World Wide Web, which is on the top of the internet, was not designed to run identity. There was an hyperlinked environment that was done by CERN in Geneva. I was at the UN at that time. And that has created a situation where only maybe 1 billion people on Earth has an identity. An identity is not your password or your social security number. It's actually who you are. It's your human identity, which is becoming essential to be in control of humans. Otherwise, AGI and everything which is agentic AI will basically replace your identity and take decision on your behalf without you being in control. So we provide technology that reverse that process, digital identification based on public key infrastructure. Those are cryptography root keys that they are actually Swiss, so we are not American. We are not subject to the same pressures that some of the American companies have. And that identity used on daily days. You use that for payments, for voting online, to pay your taxes, and if you even wish, you could also use those identity to train AI. AI is becoming now a big subject everywhere, but AI will only be interesting from the point of use if that is related to your identity and you have the final key which is under your control and your consent. If not, AI will replace you, and then we enter into a very serious problem.
Well, just on the subject of AI, as you're touching that, do you feel that AI and IoT increase cyber risks? And how should organizations redesign their cybersecurity systems to stay secure against new threats? Is physical AI an option for them?
Exactly. So I've been talking all the day around Davos about the concept of physical AI. Until now, we are talking about AI that is being trained by basic information that we collect on the web. This is not enough. AI cannot work properly if it doesn't have access to premium information, which is not necessarily available because the good information is still on silos. So if you want to train an AI with an LLM on medical data, for instance, you will not find the required information to do that properly. So in the next thing coming now is that we are connecting 7 trillion objects to the internet. So everything is going to be connected to the internet. Everything that is on this room will be connected.
That's a big number.
7 trillion. And those objects need an identity in order to be only identifiable as a one object, so you cannot duplicate it. And you will also connect those objects to the internet in a secure manner. And this is what we call the physical AI. So the object will then be autonomous. The object will be able to learn its behavior. So if you have instructed an object to do something, let's say a robot, actually we just brought a robot in Davos, it's going around the city, and that robot will not be able to go against your will because that physical identity is under the control of your digital identity. So this is the only way we can enter into the fourth industrial revolution, which is everything is going to be connected. This is an endeavor. That's how our companies become so big so fast, because you need somebody to provide that layer that does not exist on the web, and that's what we do. And this is actually being even accelerated by the fact that now we have post-quantum encryption and quantum computers arriving.
Exactly, that's another hot topic, quantum. And so what are your thoughts on how large organizations, what they need to do to be quantum compliant today?
So I just came from a roundtable with IBM, and IBM today actually confirmed that by the year 2029, which is tomorrow, they are going to be able to have a quantum computer with 10 million qubits, which is the measure of performance of a quantum computer. So qubits is the computational level that allows a quantum computer to do more sophisticated things until the point that reaches the 10 million qubits, which is what will break RSA. So the entire world now, for the last 50 years, is based on RSA, triple DES encryption. So your credit cards, your car, your house, your alarm system, everything is based on RSA. And a quantum computer in 29 will be able to break RSA. So by breaking RSA, it breaks all the secrets. You know, everything needs to be replaced. So there is a company like us that manufactures semiconductors and they are PQC compliant, means that they will defend a quantum attack. And that's how we started. We launched that 2 years ago. And the activation of that was Google came with Willow, which is a core quantum asset that allows basically the development of quantum computer faster than everybody thought. Everybody thought that quantum computers will arrive in 2030. Even the CEO and NVIDIA is at the beginning of the year last year saying, no, this is a 30 years issue, but it's not actually, it's now. Yeah. So the companies that they are on the defense side, they are helping companies like banks, insurance company, hospital, airports, smart city, to create a PQC software layer on the top of their legacy layer. And that layer then is interconnected with whatever devices that layer needs to monitor. And as I said before, if you are not compliant with the new legislation in the United States, they call it that, the CNSA 2.0, which is a legislation that says that you have to be PQC compliant before the year 2027, or you will have to stop operating, as simple as that. So it's a major issue that needs to be solved.
On another topic, defense spending is increasing. How do you feel about defense technology, which has often driven civilian innovation? Do you see it influencing everyday technologies as well today?
Exactly. The next battlefield is space. You know, for actually in Switzerland, our company develops with the Swiss Army a constellation of satellite. We have launched 20 satellites already. Those are PQC satellites, so they are able to encrypt the message from the space. We did that with the SpaceX. We are launching 100 satellites more, because in the future, I mean, already satellites are the best way to capture intelligence anywhere in the world. Because satellite with optical capabilities, they can zoom into anywhere on Earth and detect movements. Let's say that a country wants to invade another country and they are moving tanks and soldiers, you will be able to see that from the satellite. Or a fire gets out of control, you will see that. So basically what companies like us are doing on satellite is like Google is doing with the internet. You are indexing the physical world, the world that matters, really, the world that we are living. You know, the satellite will be real-time connected to your infrastructure and being able. So this is obviously whoever has this technology, it has a battlefield advantage to another person. Also in the defense system, the army's concepts are changing. For instance, in Switzerland, it's no point to have those kind of very expensive plane, because the attack is not going to be air attack. It's going to be a missile blowing away the command centers. So the new design is decentralization. So there is no more a centralization of a command center in one place. You rather distribute that all over the country, and you connect all that through your own constellation of a space to avoid a military action to where you might have the control system. So this entire space industry is giving ideas on how to protect yourself. As in the next 5 to 10 years, everything is going to go to the space. Now is low orbit satellite. In the future, it's going to be compute on the space, which is cheaper because you don't need air condition anymore. You don't need energy. You capture that from the solar energy. And information is available now. Even people thinking of putting data centers in the space. So the space is the next big opportunity.
So technologies like Starlink will continue maintaining connectivity during crises. But do you feel that governments can keep up with privately owned global networks?
I mean, the problem with the Starlink or any of those very large constellations is that they are not sovereign constellation. Or if they are sovereign for one country. We know which one is, right? So that means that other countries, in case of a friction, of a battlefield situation, or even a commercial disagreement, they might shut down the access to the space. So I just came from India. I was in India. Israel, for instance, is sending their own satellite constellation. Taiwan is doing the same thing. So Switzerland is doing the same thing. I mean, you don't need a Starlink. Starlink was a great proof of concept that space it can be monetizable, and you can make money out of space. I mean, they are making an IPO $1.5 trillion, so that shows that the space is a good business. But every country would like to have their own access to the space, and you don't need either to have thousands of satellite constellations. Satellites are getting more and more powerful. Or the first satellites we made, those are picosatellites. They are big like that. Now they are much bigger and they are more powerful. And the technology of the satellite is improving on a daily basis. So in the future, one of those very sophisticated satellites might replace thousands of the Starlink satellites. So Starlink is not the final destination. It's actually the beginning. It's like Google was for indexing the web, you know, because they arrived very early. And they got a lot of support from the US government in terms of financing them, which we don't have in Europe, right? I mean, the Europe is the entrepreneurs and they have to invest rather than having government or public institution putting the money.
One last question, coming back to Monaco, which has established its own sovereign cloud recently. Do you believe that digital sovereignty will be the future for nations?
It is, but not on cloud, because a quantum computer, the first thing they're going to do is break a cloud, right? So we just acquired a company in Grenoble with the name Kubli. It's a $200 million acquisition, which has been announced a few days ago. And this is a French quantum company, so they are developing their own quantum computer. So this type of companies, together with CLSQ, they are the ideal partners for verticalizing the sovereignty of the technology. And it's not only cloud. You have to own your cryptography root key. You have to have your own digital identities on server and data. You have to have your own encryption. You have to have your post-quantum technology. You have to have your own quantum computers, because quantum computers will attack each other, right? Yes. And the first thing that quantum computer break will actually be a cloud. So this notion that I do a cloud and I am sovereign, this is a very déjà vu. It's a very old notion. You have to go much farther.
Much beyond, that.
Yeah.
Well, thank you so much for your expertise insights. Perhaps we've got 3 minutes left. One question from the audience, as we have a world-renowned expert here. Everyone is a bit shy. One last question.
Can you make a comment on...
Maybe just wait for the mic. Thank you very much, sir.
Can you make a comment on compute as an asset, compute power? Are you thinking about that as being something that actually could be tokenized? The unit of compute capability.
So now the only way then you can compute is on very extensive installation data centers that cost a lot of money with a huge demand on electricity, and this is the inflation point where trillions of dollars has been invested in Saudi Arabia and so on, and the United States in order to do this type of installation, in order to increase the computer capability. This is going to be different when a quantum computer arrives, because the quantum computer requires less energy, actually nearly none energy at all, and it doesn't need a data center. You know, one quantum computer replaces something like 5,000 to 6,000 supercomputers. So this is going to redesign the investment community, because now everybody's like, crazy putting billions of dollars in building infrastructure, which is actually wrong infrastructure. This is creating huge environmental issues. People are losing control of their energy. Some people in the United States now, they don't even have energy access anymore because data centers are absorbing that. So that is the wrong model. The real model is going into quantum capabilities. Quantum will accelerate, and quantum can be dangerous for things I mentioned before, but quantum is also amazing for developing new drugs, developing sustainable development goals, find solutions for them. We have been trying for nearly 5 decades, and we never find solutions. It will be a new way to protect assets, but it will also be a very, a lot of people here are crypto people, Bitcoin owners, and others. A quantum computer will be able to break the algorithm. So we are in a power shift model from where we are going on this kind of physical Earth infrastructure to a space infrastructure and quantum infrastructure. So the final destination is quantum space.
Thank you so much, Carlos. That was very precise, and thank you again for your insights and expertise.
Thank you very much.
Thank you. I think we need to take one picture.